Hello everyone, today I'm going to discuss a problem in physics based on the relative motion, which is commonly known as the Riverman problem. First of all, I'm going to discuss what is relative motion. Say for example, you're inside a car and you observe a tree on the road which is standing still. To you, you'll feel that you're standing still inside the car and the tree is moving backward. How can we explain this system by using physics? We can take an equivalent system where we consider that the car is point A and the tree is point B. Say for example, it is moving at some velocity 10 meters per second. We need to make this A stand still, we need to apply an opposite velocity. We are applying some change to A. We need to apply the same change to B, that is negative 10 meters second minus 1. So in this case, this has become still and this is moving in a negative direction. This can also be demonstrated by the fact that velocity of B with respect to A can be written as velocity of B with respect to ground minus velocity of A with respect to ground. So velocity of B with respect to ground, the tree is standing still with respect to ground, so it is 0, and velocity of A with respect to ground is negative, is 10 meters per second. So that is why velocity of B with respect to A would be negative 10 meters second minus 1, which is equivalent to this negative 10 meters per second minus 1. Now if B is also moving at some velocity, say for example, if this was a car and it was moving at a velocity of 5 meters per second in this direction, then in that case velocity of B with respect to ground, velocity of B with respect to A would be, velocity of B with respect to ground would be negative 5, because this is the negative, this is negative direction, this is positive direction. So negative 5 and minus 10 meter 10, so this would add up to be 15 meters second minus 1. So which means that A would absorb B to be moving more quickly in the backward direction. Now this was the case when A and B were moving in the parallel line, but if they were moving in some other direction, say for example this was another car which was moving at 90 degree to this direction, then in that case we need to consider a vector negative. For example, velocity of B with respect to ground is this direction, and this negative velocity of B with respect to ground, vector negative, should be considered, which means velocity of A with respect to ground is this direction, negative would be this direction. So overall the velocity of B with respect to A would be in this direction. This is velocity of B with respect to ground, velocity of A with respect to ground, this is velocity of B with respect to A. Now let us understand the problem to make this idea more clear. So in this problem we have been given a man can swim with 10 meters per second in still water. The speed of the river is 6 meters per second. Find number 1, minimum time to cross the river, and drift, time taken to cross the river by minimum path. We have also been given the width of the river, that is 100 meters. Now first of all we need to identify different velocities, because in this formula suppose there are two entities, that is man and water. So velocity of man with respect to water can be written as velocity of man with respect to ground minus velocity of water with respect to ground. Now when we are talking about velocity, then we talk in relative terms. That means the velocity, this velocity, a man can swim with 10 meters per second in still water. What does this mean? That is that the velocity of man with respect to water is given as 10 meters per second. Also the speed of the river is 6 meters per second. Now this means that the river is on the ground, which means velocity of water with respect to ground is given as 6 meter per second. We have identified two velocities. Then we start the problem. Before starting up the problem, we need to develop some intuition about the problem. So say for example, this river was still, it was not moving, it was still, and there was a man at this point. Now if he move in this path, then we can obviously say that he has to travel the least amount of distance, and he would cover that path in the minimum time. If he start in any other direction, then he might have to cover a larger distance, so it will take more time. Secondly, if the river is moving, in that case, if he start in this direction, then he might end up at some other point. He was hoping to reach here, but he might end up to some other point because the river would be drifting him to this point. Now so in that case, if he want to reach at this point, then he need to start off in this direction so that he gets drifted to this point. So if you consider the second question, time taken to cross the river by minimum path, this is the minimum path. We would require the person to reach to this point, so he needs to travel to this path, and he is starting in this direction, which means that his velocity, the velocity of man with respect to water, is in this direction. And we already know that the velocity of water with respect to the ground is in this direction. So this would be the velocity of man with respect to ground. So we can use the vector equation, but first of all, if this person has started at an angle of theta with this line, this perpendicular path, here it needs to be noted that this is the magnitude of the velocity of man with respect to water, that is 10 meter per second, and this is the magnitude of water with respect to ground, velocity of water with respect to ground, that is 6 meter per second. We have figured out that he needs to move in this direction to end up at this point, but to define the velocity, we need to define its magnitude as well as direction completely. So in order to do that, first of all, if this is his direction, this is the direction of this velocity, then it can be resolved into two components, that is 10 sin theta and 10 cos theta. And you can write velocity of man with respect to water as 10, this is negative direction, this is negative x direction, so negative 10 sin theta I cap, plus this is positive y direction, that is 10 cos theta j cap. These are the unit vector in x direction and unit vector in y direction. It can be written as that, like this is unit vector in x direction, this is unit vector in y direction. Now and to define this completely, velocity of water with respect to ground, we can write 6 I cap, because it has just it is moving in this x direction. Now we can use this equation in order to be able to find this velocity of man with respect to ground. So we can write this velocity of here, we can plug in these two values, that is velocity of man with respect to water is negative 10 sin theta I plus 10 cos theta j is equal to velocity of man with respect to ground needs to be found out, and velocity of water with respect to ground, that is 6 I cap. Now therefore we are getting velocity of men with respect to ground, that is 6 minus 10 sine theta I cap plus 10 cos theta j cap. If you take this side, and I can be taken common, and you can write this. Now we know that the person has to reach to the other end by the shortest path, so that means his direction would be in the positive y direction, which means that this velocity needs to have only the y term. The x term has to vanish. So which means that we can equate 6 minus sine theta to be 0, or from there we can find the value of sine theta, that is 0.6. You can calculate that value of theta. Sine inverse of 0.6 would come out to be 36.8. So which means that the angle would be 36.8 degrees. So that means that the person has to start at an angle of 36.8 degree in order for him to cover the this path by the shortest distance. Now by using the value of theta, we can also determine the velocity of men with respect to ground. Can be found out. This component is 0, so 10 cos 36.8 j, we can determine the value. Cos 36.8 into 10 is equal to 8 j. So velocity of man with respect to ground is coming out to be this much. Now we can use the simple speed equal to distance upon time, because we already know the distance he needs to travel is 100 meters, and we have determined his speed, that is 8. So speed equal to velocity of man with respect to ground is equal to distance 100 per unit time. This is 8 equal to 100 per unit time, which means that his time would come out to be 100 divided by 8, that is 12.5. So in order for the person to reach by minimum path, he will take 12.5 seconds. Now in order to determine the minimum time to cross the river, we need to understand the fact that if the man is at this point and if he starts in this direction, then due to the flow of the river he would be drifted to a longer distance, and it would take a longer time for him to cover the distance of the width of this river. On the other hand, even if he starts in this direction, then since he has to go against the flow of the river, so he might end up at any point, and it would take a longer distance than the minimum. But on the other hand, if he starts in this perpendicular direction, then even though he would be drifted to some other point, it will take the least amount of time to cross this river. So to cross the river at the minimum time, we need to start in this direction, and that would be the velocity of man with respect to water. Now we have already determined the velocity of man with respect to water, and we have discussed the direction of that vector. So in this formula, if this theta would become 0, then he would move in this direction. So if we plug in the value of theta in this equation, then sin theta is 0 and the velocity of man with respect to water would be just 10 j cap. And in order to determine the time, we already know the distance width of this river, that is 100 meters. We can directly use the formula V equal to width, distance, velocity equal to distance per unit time. We already know the velocity, that is 10 meter per second, 100 by time. So the time is coming 10 seconds. So we have determined the time. The another question that is being asked is the drift. Now what is the drift? So in this case, if he starts in this direction, the water would drift the man to some distance, that is this x. We have to determine this distance x, and he would drift to this point with the velocity of water, that is 6 meter per second. So we have already determined the time, that is 10 seconds. We can use again the same formula, that is velocity equal to velocity of water with respect to ground is equal to x by time. So x equal to velocity of water with respect to ground is 6 meter per second. 6 into time we have already determined 10 seconds. So his drift would be 60 meters. So in this way we can solve this problem.